Galaxies in our universe are performing a truly mysterious act. They are rotating at such high speeds that based on the visible matter alone, they should have been torn apart a long time ago. The gravity created by the star's gas and dust we can observe is not nearly strong enough to keep them together, yet they remain intact, spinning calmly as if some invisible force is holding them in place. This strange behavior has puzzled scientists for decades, and it has led to the fascinating theory that something unseen, something we have yet to directly detect, must be playing a key role. This something is what we now call dark matter, a term that captures both its mysterious nature and the fact that we cannot observe it through conventional means like light or radiation. Unlike normal matter which interacts with light and can be seen with telescopes, dark matter does not absorb, reflect or emit any electromagnetic radiation. This makes it invisible to our eyes and our instruments. We cannot take a photo of dark matter or observe it directly in a lab. Instead, scientists have inferred its existence only through its gravitational influence on visible matter. Stars and galaxies seem to be under the influence of far more gravity than can be explained by the matter. We can see this gravitational pull keeps galaxies from flying apart and helps them maintain the shapes and speeds that we observe when we look into deep space. This is not an isolated phenomenon, it happens across the universe, suggesting that dark matter is not rare or exotic but incredibly common. It is estimated that dark matter makes up about 27% of the universe's total content in comparison. The matter we know, the stars, the planets, the gas and dust that form galaxies, only accounts for 5%. The rest of the universe, around 68%, is thought to be dark energy, another mysterious force driving the accelerated expansion of the universe. But while dark energy pushes the universe outward, dark matter pulls it inward, acting like a cosmic glue that helps galaxies stay bound together. Scientists have proposed various theories about what dark matter could be. One of the leading ideas is that it is made up of particles we have not yet discovered, particles that do not interact with light but still exert gravitational force. Some researchers believe these particles might be what are known as supersymmetric particles. These are hypothetical particles predicted by a theory called supersymmetry, which suggests that every particle in the standard model of physics has a heavier partner. If this theory is true, then dark matter could be made of these partner particles which have not yet been observed but may exist in vast numbers throughout the universe. To try and detect these elusive particles, scientists have turned to powerful tools like the Large Hadron Collider located at CERN near Geneva, Switzerland. This enormous machine accelerates particles to nearly the speed of light and smashes them together, recreating the conditions of the early universe. In these high-energy collisions, researchers hope that dark matter particles might be produced. If such particles do appear, they would not be detected directly. Instead, they would escape from the detectors unnoticed, but their presence could be inferred by measuring the missing energy and momentum in the aftermath of a collision. Imagine looking at a puzzle and noticing that some pieces are missing, not because you can see the missing pieces, but because the picture is clearly incomplete. This is the strategy scientists are using. They are looking for the gaps, the unexplained losses of energy that might point to particles from the dark sector beyond supersymmetry. There are even more exotic ideas. One fascinating concept is the idea of a hidden valley, a parallel realm made entirely of dark matter, where the laws of physics may be very different from those we know. This hidden valley would be almost completely invisible to us, but it could influence our universe through gravity, just as dark matter does. Some theories propose that dark matter might be spread out through extra dimensions that are hidden from our perception. In these models, the universe we know is just a slice of a higher dimensional reality, and dark matter could be leaking into our world from these unseen dimensions. These ideas might sound like science fiction, but they are taken seriously by physicists because they provide possible explanations for one of the greatest puzzles in modern science. For now, dark matter remains invisible but not undetectable. Scientists continue to build new experiments on Earth and in space to capture its faint signature. One example is the alpha magnetic spectrometer, aboard the International Space Station, which searches for dark matter by detecting cosmic rays from deep space. Other experiments are taking place deep underground in shielded chambers where scientists hope to detect rare interactions between dark matter and normal matter. Using ultra-sensitive instruments, no conclusive evidence has yet been found. But the search continues because solving the mystery of dark matter could change our understanding of the universe forever. Imagine if one day we not only detect dark matter but learn how to use its properties. This could revolutionize science, technology, and even space travel. Understanding dark matter would also help answer deeper questions such as how galaxies first formed, how structures emerged in the early universe, and perhaps even how the universe will end. The story of dark matter is a reminder that we still know very little about the cosmos we inhabit. We tend to believe that with our satellites and telescopes and theories, we understand a lot. But the truth is, most of the universe is still hidden from view. We are like people trying to understand an ocean by looking at the waves on the surface. The real depths remain unseen and mysterious. Yet, this mystery is what makes science so exciting. Every new discovery adds another piece to the cosmic puzzle. Every experiment, every theory, every unexpected result brings us one step closer to unveiling the nature of dark matter and with it the true nature of our universe. But here's something even more mind-blowing. Scientists believe that dark matter might have been the key to the formation of the first galaxies. Without this invisible force, the early universe may never have clumped together into stars or planets or anything at all. Think about that. We owe our very existence not just to the matter we can see, but to a cosmic shadow that we cannot. Every breath we take, every star we wish upon, every planet discovered in a faraway solar system may be shaped by this mysterious and silent force. And we are only just beginning to scratch the surface of this hidden reality. We once thought the universe was made for us, but dark matter reminds us that most of it is not even made of us, or for us it is alien, unfamiliar, and yet it is the reason galaxies spin, why stars cluster, and why the universe holds its shape. We may never fully see it, we may never touch it, but we are surrounded by it. It is the cosmic scaffolding that holds everything together, from the smallest dwarf galaxies to the largest galaxy clusters. The next time you look up at the night sky and see the stars twinkling, remember that what you are seeing is just the tip of the iceberg. The real engine behind it all is invisible, silent, and yet more powerful than anything we have ever known. And who knows, maybe one day dark matter will no longer be a mystery. Maybe we will unlock its secrets and use them to reach other stars or even other dimensions. Because in the end, the universe is not only stranger than we imagine, it is stranger than we can imagine. And if you found this journey into the unknown as thrilling as we did, don't forget to like the video and subscribe to the channel for more mind-blowing explorations of science, space, and the mysteries of our universe, because this is just the beginning.